So your local computer store is having a terrific sale on digital cameras, 40% off. After the 40% reduction, you purchased your digital camera for $276. Okay, so what was the camera's price before the reduction? What do you think? 460? What do you think? 560. Yeah. 690. Wow, we are all over the place. Let's see if we use algebra to get the answer, what we come up with. So what did they ask us for? The original price. So in general, when you're solving a word problem, look for the question first, right? What was the camera's price before the reduction? And we're going to let that be a variable, right? That's the thing we don't know, so we're going to let that be x. X is going to be the original price. Okay, so what happens? How do you take 40% off of something? Yep, so my original price, I would times it by 0.4, and that's going to be, what does that amount represent? The discount. So what do I do with it? Subtract it from the original price. Okay, so if I take my original price and I subtract 40% of the original price, right, what should I get? $276 is the price after the discount, right? Which is also 60%. So you could also write an alternative equation would just take 60% of x, and that's 276. Right? If you're taking 40% off, that means you're paying 60%. So either of those would be a good equation to solve. And over here, when you combine like terms, 1x minus 0.4x is 0.6x. So they end up being the same equation. All right, so then I'm just going to divide both sides by 0.6. $276 divided by 0.6, 460. $460. Is that okay with everybody? Okay, so that's our little warm-up. Today, we're going to deal with models and applications, which many of you know as word problems. Okay? But we in the GCC math department like to call them story opportunities because we are optimists. Right? It's not just words, it's stories, and they're not problems, they're opportunities to practice your mathematical abilities. Right? So one of our goals today is going to be to develop some strategies that will help us solve these story opportunities in order to become more confident and competent problem solvers. All right, so here we have a bar graph that shows the average yearly earnings in the US for people with a college education by final degree earned. Okay, so we've got bachelor's degree, master's degree, doctorate, and a higher professional degree. All right, so the average salary of an American whose final degree is a master's degree is $49,000 less than twice that of an American whose final degree is a bachelor's degree. Combined, two people with each of these educational attainments earn $116,000. What? Find the average salary of Americans with each of these final degrees. Where do you begin? What do you think? Okay. A step before that, what is x representing? Define some variables. Okay, so we're going to define some variables. Okay, so what I suggested in the last question was to, in the last story opportunity, right, was to find the question and use that to help you define your variables. So they are asking me to find the average salary of Americans with each of these final degrees. What are these final degrees? Masters and bachelors. Okay, so let's say X will be the average salary for one of them. Which one? Masters. Okay. We'll call it an MA. And then we need something to represent the average salary for a bachelor's degree because they also asked us for that. So we could call it Y, right? We could give it another variable, or we could try to like weed through the question and try to figure it out in terms of X. Okay, so let's call it Y for now. Okay, so the average yearly salary, I wrote the whole thing again. Strategies. Read the problem carefully, identify and describe in words the quantity or quantities you're being asked to find. So we're being asked to find average salary for a BA and average salary for an MA. Then we're going to assign a variable to one of the unknown quantities. So we can talk about how we decide. In this case, it's pretty arbitrary. Pick the one you want. Or let's see. If you go back to the question and it says someone whose final degree is a master's degree is 49,000 less than twice that. So they're defining the master's degree in terms of the bachelor's degree. They're telling you how much more or less the master's degree is than that of a bachelor's. So let's let X be the bachelor's degree. Then we want to write all other unknown quantities in terms of this variable. So I need to come up with some expression that represents the average salary for a master's degree. And it says it's 49,000 less than twice that of the bachelor's. So how would I express 49,000 less than twice the salary of someone with a bachelor's degree? 2x minus 49. Take the person with a bachelor's degree, double it, subtract 49,000. So we can just measure this in thousands if you want. In thousands. That way we don't have to write down all the zeros all the time. And that is going to be average salary for an MA. Oh, I was supposed to write that in the next block. Sorry. All right, what equals what? We need to set up an equation that determines how these two quantities are related. How are the quantities average salary for a bachelor's and average salary for a master's degree related, according to the question? Yeah, it says combined, two people with those degrees make 116,000. So combined, how are we going to combine them? What mathematical operation? Addition. We add them together. So if we add average for BA plus average for MA, we're supposed to get 116,000. Combined, two people with each of these degrees. So I think they mean one person of each. Two people, one with each of those degrees. Oh, I don't think so. Two people with each of these. Yeah, I think they just mean two people, one of each degree. Okay, so average for bachelor's, we said that was X. Average for masters, that's 2x minus 49. That needs to equal 116. And then finally, solve the equation and answer the question. So I get 3x minus 49 is 116. 116 plus 49 will be 165. Divide both sides by 3. What do you get? 55. And that's measured in thousands, right? Okay, so then answer the question. Now that I have x equals 55, check your answer using the original wording of the problem, not the equation you obtained. All right, so 55, that should be the average salary for someone with a bachelor's degree. Go all the way back to the original wording. The master's degree should be 49,000 less than twice that. Okay, so 49,000 less than double that. So if I double the 55, 55 times 2, and subtract 49, I get 61. So average salary, I'm going to do the checking after. For BA is $55,000. Average salary for an MA should be, what did it come out to? $61,000. Okay, do the two of those combine for $116,000? Yes. Do those seem like reasonable average salaries for people with a bachelor's and a master's degree? Those are reasonable amounts that someone with a bachelor's or a master's degree could expect. They agree pretty well with the bar graph. Yeah, I forgot about the bar graph. 55, yeah, and 61. Yep. And let's see, does average yearly final degree is 49,000 less than twice of someone with a bachelor's. So let's just do twice someone with a bachelor's. 2 times 55 minus 49. Yeah, that gives you 61. Okay, good. Checks out. All right, so here's another example. You're choosing between two texting plans. Plan A has a monthly fee of $20, plus you have to pay 5 cents per text. Plan B has a lower monthly fee, it's only $5, but you have to pay 10 cents per text. Both plans include photo and video, whatever you want to text, you can text. How many text messages will the cost for the two plans be the same? So I want you to, in your groups, discuss, see if you can come up with an answer, and try to follow the strategy of having a variable and naming it and solving for it. Okay, let's discuss. So, strategy. Read the problem carefully and identify the quantity or quantities you're being asked to find. So what quantity are we being asked to find? A certain number of text messages. The magic number that will make the two costs the same, right? So it won't matter which plan we choose. So T equals the number of texts. So plans are the same cost. So T is going to represent a number of texts. Okay. So, oh, we just did that. We assigned the variable same time that we were identifying the question. Okay. So now I want to write all other unknown quantities in terms of this variable. So what are my unknown quantities other than this magical number of texts? The cost of the plans. How much each plan costs. is an unknown quantity. It depends on this number t. So we're going to say we'll call A the cost of plan A, right? In fact, maybe I'll give it a better letter. Maybe I'll call it C with a little sub A to mean the cost of plan A. C of A. Okay. So plan A is $20 plus 5 cents per text. So how do I put on the 5 cents per text part? 0.05 for every text, so I have to multiply by t the number of texts. And then the cost of plan B, right, is $5 plus 10 cents per text, so it's plus 0.1 t. Now, what equals what? Plan A should equal plan B because they asked us to find this special number of text messages for when the two plans are the same. The same you could read as equal, right? When the cost of the two plans are equal. So CA should equal CB. Cost of plan A should equal cost of plan B. Then substitute in those formulas. 20 plus 0.05 t should equal 5 plus 0.1 t. Then finally, we solve the equation and answer the question. So I get 15 is equal to 0.05 t. I just subtracted 5 from both sides, and I subtracted 0.05 t from both sides. Divide both sides by 0.05, and you get 300. Okay. Now, we can, if we forgot, we should go back and remember what t represents, right? T is the number of texts. T is a number of texts. So write a sentence that answers the question. For 300 texts, the plans cost the same amount. And we should check our answer using the original wording of the problem. Okay, so why do we use the original wording and not the equation we wrote? In case you made a mistake writing your equation down. Good. Okay, so let's go back to the original wording. We know our answer is now 300 texts. All right, so plan A has a monthly fee of $20 plus 5 cents per text. So let's see how much that would cost if we used 300 texts. So $20 plus 5 cents for each of your 300 texts. 20 plus 0.05 times 300. It's $35. Okay, and then for plan B is $5 plus 10 cents for each of your 300 texts, also $35. So we are correct, $300 texts cost the same for each plan. Each plan would charge you $35. So each plan costs $35 for 300 texts. How are we feeling about this particular story opportunity? Okay? All right. So we can use our graphing calculator to numerically check or graphically verify our solutions to the text message problem. So we're going to let Y1 be the monthly cost of plan A. So that was 20 plus 0.05. We used T, but we're going to use X because your calculator doesn't have a T variable. So we'll use X now. And Y2 will be the monthly cost of plan B, which is 5 plus 0.1X. And then we're going to look at a table. 20 plus 0.05x, and 5 plus 0.1x, and look at the table. And I want x values for 100, 150, 200, 250, 300, 350. So if you can't type in x's, you go to table set right above window. And you should make sure that your independent variable is set to ask and dependent is set to auto. Yes, question? Oh, really? Do you have it? Okay. So go back to my table. Oh yeah, look at that. Thanks. 250. All right. So when I fill these in, I have $25 for plan 1. If you use 100 text, it costs $25. And for plan 2, it only costs $15. Okay. And if you use 150 text, plan 1 is $27.50 and plan 2 is $20. So far it seems like plan 2 is the cheaper option, right? 200 text, we have $30 for plan 1 and $25 for plan 2. Still looking like plan 2 is the plan to choose. $250 is $32.50 or $30. And then for 300 texts, we have $35 or $35, right? The same cost for plan 1 and plan 2 when you use 300 texts. And then once you go past 300 to say 350, $37.50 for plan 1 and $40 for plan 2, and now suddenly Y1, plan 1 would be the better choice. Yeah. Yeah, it depends on how much you text. If you do less than 300, you'd choose plan 2. More than 300, you'd choose plan 1. And if you do exactly 300, doesn't matter. So this is the point where they are the same. You look through the table for a place where the two y's are equal. And then we can graphically solve this problem by looking at a graph of y1 and y2. And the solution you find using the intersect feature, and it's the x-coordinate of the intersection point. So I'm going to go y equals, I already have my equations there. I have to choose a window that makes sense. So what was x representing here? Amount of text messages. So I'm going to start at 0 and maybe go to 350 or 400. And then what is y representing? Costs. Yeah, either cost of plan A or cost of plan B. So my costs, I know from the table, range from $15 to $40. So I think I'm going to go like 0 to 60. Just a range of costs that you would pay for texting. And then I press graph, and I have y1 and y2, and I see that they cross somewhere. That place where they cross is where they are equal. So I'm going to use the intersect feature. It's in the calculate menu. Press second trace, and you choose option 5, intersect. And it takes you back to the graph screen, and the cursor is flashing on one of the lines, and it says first curve. They're asking you, is this one of the lines that you're trying to find an intersection for? You tell it yes by pressing enter. Yep, that's one of my lines. And then it says, is this the second curve? And you say yes by pressing enter. So if you only have 2 lines, you don't even have to think about it. You just press enter, enter, right? The reason you have to tell the calculator is because in the y equals screen, there are like 10 possible entries. If you had them all filled in, you would have to pick which 2 lines you were looking for the intersection of. All right, so finally, we have to make a guess. So we just take the cursor and we put it somewhere close to where they intersect. Doesn't have to be perfect. Press enter. And it tells me that the intersection happens at 300, 35. 300 texts for $35. There we go. So you have 3 ways now of solving the equation. You can do it algebraically, you can use a table of values, you can use a graph. All right, now we have a dual investment problem. So a scholarship fund has $10,000 in it. So someone donated $10,000 to a scholarship fund. So the people who run this fund say, okay, well, we could give this money away once and not have any money left. Or we could invest this money, have the money make money with interest, and then we might be able to give away more money over the long run. Like we could make this $10,000 go further by investing it. So we have 2 options. We have 2 funds. One's low risk and one's a little bit higher risk. And from the low risk fund, we can expect a return of 4% annually. And from the high risk fund, we get 8% annually. And we want to have an expected return of $550 a year with as little money in the high risk fund as possible. So how much should we invest in each fund? So the idea being that we want $550 a year return because maybe that's the amount of our scholarship. We're going to give out $550 a year, and this way we'll never run out of our original $10,000. We just each year we make $550 in interest and we give it away, right? And we still have $10,000. So we want to make this $550 with the least amount of risk possible. We don't want to put more money in the high risk fund than we have to. So we can solve this problem using 1 variable or 2 variables. Many of the problems can be used 1 or 2. Your text demonstrates how to use 1 variable. So for this one, we'll do 2 variables just so that you can see something different. And some of you will have used this technique before. Okay, so step 1, find the question. What are they asking me? Yeah, how much do we have to invest in each fund to make the $550? So let's let X be the amount invested in the low risk, right? And we'll let another variable Y be the amount invested in the high risk fund. Okay, so we've defined 2 variables because they asked us a question about 2 different things, right? How much should we invest in each of these 2 funds? All right, so some students find using a table helpful for performing these steps and figuring out the what equals what part and all your different expressions. So I'll show you how we use it. So we're letting X be the amount invested in low risk and Y be the amount invested in high risk. Always define your variables before you start doing anything else. Then you can fill in this little table where you have the lower rate, the higher rate, and the total. And we have the amount invested, the percent interest we're going to make, and then the amount of interest we're going to make in dollars, right? How much we'll make in dollars. So we already decided we're letting X be the amount we invest in the low rate and Y be the amount we invest at the higher rate. And what's my total investment? X plus Y, which is how much money? Close, no. $10,000 is what I'm investing. I'm investing a total of $10,000. And then my percent interests, my lower rate, that was 4%, and my higher rate was 8%. They didn't tell me anything about what the percent return is on the total, so I'll leave that blank for now. And then the amount of interest you make. If you invest X dollars and you make 4% interest, how much money will you have at the end of the year? How much money will you have made? 0.04x, yeah. You just multiply how much you invested times the percentage, and that tells you how much money you made. Right, so if I invested $100 at 4% interest, You take 4% of 100, that's $4. That would be my interest at the end of the year. So at the interest I'm going to make on my higher rate is 0.08 times y. 8% times however much I invest in there. And then how much interest am I hoping to make on the entire investment? $550. They told me that outright. I don't have to do any work for that one. Okay, so I've defined two variables, which means how many equations do I need? Two. Yep. Two unknowns, you need two equations. So you said earlier, how are x and y related? Yeah, x plus y equals 10,000. When you add up the amount of money that you invest in the lower rate plus the amount of money you invest at the higher rate, you invested 10,000 total dollars. So x plus y has to equal 10,000, so that's one equation. And then if I go over to the last column, the amount of interest I make on one investment plus the amount of interest I make on the other investment is supposed to add up to $550. That's my goal. I want interest from this investment plus the interest from this investment to give me the 550. So I've got 0.04x plus 0.08y should equal 550. Now, who remembers how to solve a system of equations? Two equations, two unknowns. Yeah, you can do that. You can do the cancellation method where you multiply everything in one equation by something so that two of them will cancel when you add them. Or you could use substitution. Right, so you take one equation and solve for one of the variables and then substitute into the other equation. Either one is fine. Use your favorite method. For this particular problem, I like substitution because it's really easy to solve for x or y. You just move one of them to the other side. So let's say I will say x is 10,000 minus y, right? And then substitute over here. Wherever I see an x, I'm going to replace it with a 10,000 minus y. So I have 0.04, and instead of times x, replace it with what x is equal to, 10,000 minus y plus 0.08y equals 550. So now we just have one equation with one unknown, and we've just solved it. So 0.04 times 10,000. Well, 0.01 would mean move the decimal place 2 to the left, and then 4, so that would be 400 minus 0.04y plus 0.08y equals 550. Combine my like terms, and I have 0.04y. Subtract 400 from both sides, and I get 150. So divide both sides by 0.04, what do you get? $3,750. 3,750. So which one is that? Should I put 3,750 in the low risk or the high risk? High risk. Remember, we defined Y way back at the beginning here as amount in the high risk fund. So we're going to put 3,750 in the high risk and the remainder of the $10,000 in the low risk. So it's important, I ran out of space here, but it's important to write a sentence that has your final answer. So we're going to put $3,750 in the high risk fund, and the remainder of my 10,000, which I would get by just subtracting, and that would come out to $6,250 in the low risk fund. All right, so last thing we're going to look at in this class, I think, let me just check here. Yeah. Last thing we're going to look at is solving an equation for one of its variables. So if you have an equation that has more than one letter in it, you can always solve for one of the other letters by using the same procedures we use when you're solving for a single lettered equation. Just pretend all the other letters are numbers. You do the exact same stuff. So for example, you might be familiar with this model, distance equals rate times time. Right? So we say that this formula or equation is solved for the variable d because d is alone on one side. And the other side does not contain a d. It would be useful for some situations if you're asked to find a distance and the value, if you're given the values of the rate and time, but sometimes we might want to rewrite this so that we can solve a problem for rate or for time. So if I want to solve d equals rt for t, that just means get t by itself on one side. So how could I get t by itself there? Divide by r. So that way on the left, the r's cancel, and I end up with t equals d divided by r. Not so tricky, right? Just pretend all the other letters are numbers. Do the same stuff, same thing. All right, so here is a trickier one, though. We have the formula A equals P plus PRT. It describes the amount A that a principal of P dollars is worth after T years when invested at an interest rate of R. So it's, again, if you invest P dollars, A is the amount of money in the account after T years. We want to solve this formula for P. So A equals P plus PRT. I want to solve for P, which means just get P alone, right? I want to get P alone on one side of the equation. So what do you think I should do? Minus PRT. Okay, so I have A minus PRT equals P. So if I know A, R, and T, can I just plug them in and have P here? I want to have P. I do have P alone on one side here, but I want this to be the only place where P shows up. There can be no P's on the other side if I'm... Okay, so instead, alternate approach here. If I have A equals... I hate this smartboard. Okay. P plus PRT. What do you want to do, Katrina? Yeah. Yeah. It's a good thought. What if my equation, instead of looking like this? Yeah. What if my equation looked like P, and instead of PRT, it looked like 5P? What would you do then? You just add them together, right? You add the coefficients. Okay, go back to this one. I have 1P. I have A equals P plus RT P, right? Because I can do multiplication in any order I want. So I have 1P plus RT P's. How many P's do I have? I have 1P plus RT P's. So go back to this example. How do you get 6P here? I added the P's together, right? So I had a 1 here and a 5 here, so I went 1 plus 5 P's, like that, right? Add the two coefficients together. So here my coefficients are 1 and RT, so I'm going to add them together. 1 plus RT P's. You can also think of this as factoring out a p, right? There's a p in both terms, so you can factor it out, or some people, not some people, mostly just me, call this reverse distributing, right? So I'm taking the p back out of both of them, or reverse distributing, which means that if I take my p and distribute it in this step, if I were to redistribute my p, I would get p plus PRT, right? So I've factored out a p, or you can just think of it as combining like terms, right? I have a p plus RTPs, we combined like terms. Now I want to get the p by itself. What do? Divide by 1 plus RT. So cancel, cancel, and p equals a divided by 1 plus RT. So when the thing you're trying to solve for is in two different terms, combine them, right? Combine them into one term, which you can also think of as factoring out a p, factoring out the variable. All right, so we have a good 15 minutes left. That's great. I want you to work on this worksheet, modeling with linear equations. There are 3 of them. I want you to define one or more variables, write and solve an equation or equations, okay, and discuss with your groups. Make a table if you want, like we did for the investment problems, and I will come around and help if you need it. So the selling price of the refrigerator is $584. That's how much you're going to buy it for, like in Home Depot, right? Or Best Buy, or wherever you're going to go buy your refrigerator. It's $584. There was a 25% markup from the dealer's cost. So the dealer, like Home Depot, right, bought this refrigerator from the company that made it, like Frigidaire or something. So Frigidaire sold it to Home Depot for some cost. We'll call that D, the dealer's cost. So let D equal the dealer's cost. Okay, so Home Depot bought this refrigerator for D dollars, and they're going to mark it up by 25%. So that means that they're going to sell it for $584, and that includes a 25% price increase. So when they sell it, they're going to sell it for D, you know, what they bought it for. They want to get all that money back, plus another 25% of D. They're going to put a 25% increase, so plus 0.25 D. There's your 25% markup. That should equal the $584 selling price of the refrigerator on the floor of Home Depot. And so we solve this equation, you get 1.25 D. 1 D plus a quarter D is 1 1/4 Ds, equals 584. Divide both sides by 1.25. And what do you get for D? Somebody has it, I think. 467 point what? Yeah. So $467.20 is what the dealer paid. We should double check. Okay, if I take the dealer price and increase it by 25%, 467.20 times 1.25, I get 584. So I know that's the right answer.